Good morning. Today's video is going over our digital notes journal. This digital notes journal is in your Schoology folder for your class. Make sure that you're being careful because you will have access to this during your final assessment tomorrow. Uh, so the first few pages we've gone through already. So I'm just going to take you through those quickly, and then we are going to move on to dilations. Okay, the first is our key vocabulary. I've gone ahead and filled in all the vocabulary terms. So at this point, you're going to want to pause the video and make sure you have all of these definitions. Remember, if you pause on Schoology and it freezes out on you, please click the link to my YouTube video so you can pause freely. All right, so review of what transformations are. We call these reflections, translations, and rotations. These are our rigid transformations, and what's most important about those is even though the position may change, the shape is congruent. So we name our transformations as pre-image and image. So our pre-image is the original image, and it's just named by its vertices. The image is the result after a transformation or a series of transformations, and it's also named by its vertices with that prime, I prime, R prime, T prime. All right, so our first thing we did was translations, and these are our slides. So it's moving every single point on a figure the same distance in the same direction. We only take our slides in the X and Y directions. We are not doing diagonal lines quite yet. So if you remember, we have, if you look at the diagram, we have image, pre-image ABC, resulting in image A prime, B prime, C prime. Well, what are some of the rules? So if you look at our coordinates, x plus 2 and y, we move the image 2 units to the right, and it stays on the same y coordinate. Or if we see something like this, x and then y minus 4, well, we're only moving it up and down at that point, and this one moves 4 units down. And then this last rule, x minus 4, y plus 5, matches our diagram. And as you see, it's moved 4 units to the left, which is x minus 4, and 5 units up, which is plus 5. Made a mistake there. So this is up. Okay, so that right there is your rule. So if I give you a translation rule, you should be able to tell me what the new points are. And always look at these vertices. As far as the figure is concerned, the whole thing will move as long as the vertices are moved and connected. You will have a new figure there. Okay, on to reflections. So you guys are still calling these flips, which is a good way to remember that it just reflects, it flips over a line of reflection or symmetry in order to create a mirror image. So these are congruent, same distance from the line of symmetry. We're focusing most on the line of symmetry being at the x or y axes, but remember, we can also see a line of symmetry at x equals -1 or y equals 3. Okay, the reflection over the x-axis will change the sign as the y-coordinate at its opposite. So you see that right here reflecting upon the x-axis. The image coordinate will be 4, -2. okay? And if we reflect 4, 2 about the y-axis, it says it changes the x-coordinate to its opposite. So it's negative 4, 2. So obviously be very careful about that. I misread these. This is x-axis. So if you see here, this is our y-axis, and we flip this figure over. So our c, which is at 2, now becomes negative 2. But our y location remains the same, which makes sense. So both of these are at negative 2. Okay. A reflection can be across a line of symmetry. It's not an axis. It's just important to use distance from the line of symmetry, okay? Because we have these rules for flipping across axes, X and Y axes. But when those rules come from using distance from the line of symmetry, okay? Okay, so now we move on to rotations. Reflection moves an image. Oh, a rotation moves an image by turning. Because we're going to have to make some corrections. Turning at about a central point. Okay, we determine the rotation by direction in degrees. So when we talk about that central point, remember right now I said we are only using the origin. Each rotated point of the preimage should be the same number of units from the point of reflection, creating a congruent figure. Again, this is our last type of transformation that's a rigid congruency. So we are going to stay congruent. So it's very important to remember the translations, reflections, and rotations create congruent figures. All right. Okay, your center rotation will be the origin unless noted otherwise. We won't note otherwise. So, let me just mark this out. Unless noted otherwise, you will not have to worry about that. It's important to know, but you're not going to have to worry about it. It will be the origin. A positive angle of rotation moves the pre-image counterclockwise. So I know there was confusion for that. We always move to the left. And the reason for that, if this is my coordinate plane, this is quadrant 1, 2, 3, 4. So if you know your quadrants, you know you always move counting 1, 2, 3, 4. That's why it's counterclockwise. If you were to make that negative, it would move clockwise, but we are going to parenthesize that because we are not going to worry about seeing a negative angle of rotation on your test. Okay, so if you look at this diagram here, center rotation will always be the origin. It's 0, 0. Our angle of rotation, this is a positive 120 degrees. That's how much it's rotated. But your angles will always be in 90. So we're going to go 90, 180, 270, and 360. And 360 brings us full circle all the way back to the pre-image. So it changes the coordinates when positively rotated. So we see a rotation of 90 degrees on the coordinate axis, centered at the origin here. Okay, so you got to remember these are being rotated. That's not simply a translation. So the orientation or the way the figure is faced will change. But it does coordinate with we can write rules for how X and Y changes. Because these points are still the same distance away from a center of rotation. Okay? So when we look at X and Y, let's go ahead and look at coordinate B. The original is 1, 5. Well, when we rotate it, that X, that 1, now becomes our Y coordinate. So it's going to shift over to the right. That's what this rule means. The Y coordinate now becomes our negative X coordinate. Okay, so we move into Quadrant 1, we have a negative y and an x. So do not worry about that. Just make sure your signs match up. So you flip these coordinates, make sure I know I'm coordinate 2. So my first coordinate should be negative, my x, and my second coordinate should be positive, my y. Okay. When we move into coordinate 3, that's a rotation of 180 degrees. Okay. So everything is going to be rotated and the orientation is different, but this one is a little different. So let's look at point C. My original is 2, 5. The x and y, those digits stay in the same place. They just go to the opposite sign. So negative x and negative y. So we go from 2, 5 to negative 2, negative 5. All right, our last one right here is rotation of 270. So we go from quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4. Okay, this time we take our original xy coordinate and that becomes y negative x. So we're going to look at 2 points in this figure. Let's look at point C. If we rotate it all around, point C is going to end up in the... So our original coordinates of point C are 3, 4. So it's telling me that my x quadrant, now x coordinate from our pre-image moves to the y coordinate, and we use its opposite. So C is 3, so I should expect negative 3. And there it is. Okay. My y coordinate now becomes my x coordinate, and it remains the same sign. So my y coordinate was 4, so I should expect it to be positive 4 in my image, and it is. Well, what if I don't start one of my coordinates in the first quadrant? B starts in the second quadrant. So I'm going to still move 3, 1, 2, 3. B ends up in the first quadrant. So my x coordinate now moves to my spot y, and it becomes its opposite. So negative 1 becomes 1. And there we see it right there in the y. And my y coordinate becomes my x coordinate, and it remains the same sign. So it's a positive 4 here, so it's a positive 4 there. So B is at positive 4. B prime is at positive 4, positive 1. Okay, similar figures. So these dilations produce, similar figures are figures that have the same shape but have different sizes. Therefore, the angle measures are congruent, but the side lengths are proportional. These are called dilations, okay? So we talked about our scale factor, and that is what produces our constant of proportionality, or our K. A dilation can produce a larger image, which is known as an enlargement, or a smaller image, which is known as a reduction. So pay attention to what that prime image is. Is it larger or is it smaller than the pre-image? So always look at the prime as the one that we end up with. So you see this prime image is larger. This prime image is smaller. All right. Okay, so scale factor and dilations. So we talked about the scale factor is the center of dilation. On both of these images, our center of dilation is the origin, 0, 0. The center of dilation is a fixed point in the plane that describes change in location. So what are we dilating about? The scale factor is represented by variable k or r and describes change in size. So if it's greater than 1, it expands. So we can see this k is greater than 1. If it's between 0 and 1, or if it's a fraction, you are going to see a fraction. It's a reduction. If it's 1, there's no change in the image. It's just the same size. Dilations on the coordinate plane, enlargements. Dilations can be described by comparing side lengths. Okay, so we are going to choose the side lengths AB and A prime B prime. So we need look at the distance between these points. So we're going to choose the x-coordinate 1 and -2. So 1 minus -2 is 3 units in between. You can also count those, 1, 2, 3. And then a prime, b prime, the x-coordinate 2, y-coordinate -4, 2 minus -4 is 6. So you can also count the points between those, and it's 6. So we always set up the proportion, and I've been showing you this as a fraction also. So we have the image over the pre-image. So our image is prime, and our pre-image is just regular. So 6 over 3, k equals 2. So this is enlarged by a factor of 2. So you can multiply every point, every side length, every distance from 0, every distance from the axis by 2, and you will get your resultant figure. Okay, so talking about distances from axes or points, if DC is 1 unit from the x-axis, d prime c prime is 2 units from the x-axis. So let's determine the scale factor of that. So we have the image 2 over the pre-image 1, and we have a scale factor of 2. Again, this should be the same scale factor. We're looking at the same image. Distance from the y-axis. So we have A is 4 units away. It's is 2 units away at -2. So the distance is 2. And A prime is 4. It's at -4, so it's 4 units away. Again, the image A prime over the pre-image, 4 to 2, or k equals 2. All right, last slide. We're going to talk about our reductions. Okay. So dilations can be described by comparing side lengths. To determine scale factor, first find corresponding side lengths. So we're again going to look at AB and A prime, B prime. So AB right here is, AB is here. Pay attention to your primes. AB is here. That is 4 units. A prime, B prime is 2 units. So we've got image over pre-image. So our image is 2, our pre-image is 4, and that's equal to 1/2. So remember, your reductions are always going to be fractions. All right, distance from the axis, we can also look at that. BC, or point B, you can even take it as a single point, but this entire line here is 2 units away from the x-axis. My B prime, C prime, and you can take this as a single point also, is 1 unit away. So my image, which is my prime, over my pre-image, which is just BC. It's 1/2. Same thing here. If we take from the y-axis, we can look at the point C here, which is at 6. It's 6 away. C prime is 3 away. So let's set up our proportion. So our image, which is our larger figure here, was 6. And our pre-image, which is the smaller one, oops, our image was the smaller one. Our images are prime. So remember, you gotta be really careful, which was 3. And our pre-image was the larger one, 6. So we have all of the scale factors 1/2. Just be really careful. If you know it's a reduction and you end up with a number greater than 1, go back, flip those numbers around, and get your fraction. Just make sure you pay attention to what is the image and what is the pre-image. Okay, your follow-up work, you have your exit slip, and then during class today, we are going to take a practice test all together. So I'll see you later.